Good morning, guys. We are going to be running through our last type of transformation today, and that's going to be dilation. Before we get started, let's look at our agenda. Today, for Wednesday, the 25th, your job is to watch the agenda video, watch the Dilation Notes video, and complete the dilation drag and drop on Google Classroom. I'm sorry I keep front loading you guys with drag and drops. It's just a better practice of looking at these problems versus using my math lab. All right, and all of this is going to be due by midnight. Email me if you have any questions. So, what is dilation? Well, when I hear dilation, I think of when I go to the eye doctor, okay, and they dilate your eyes. For those of you who have been to the eye doctor, you know this process. It's when they blow a puff of air into your eyes. Whew, I hate that part. But besides going to the eye doctor, your eyes will dilate, get larger or bigger. Well, the same process is going on here. So dilation is going to be an enlargement or reduction of a figure with respect to a fixed point called the center of dilation. Our center of dilation today is going to be the origin. We will only be looking at a dilation about the origin. Dilation is different from the other transformations we have looked at. For a dilation is a non-rigid motion, meaning that congruency is not preserved. Meaning all parts are not the same, they're not congruent because we're changing in size. However, though they are not congruent, dilation images and pre-images are similar figures, meaning they have corresponding sides that are proportional, and our angles are congruent. So the only thing that's different is that our sides are not congruent, they're proportional. In a dilation figures, they will get bigger or smaller at a certain rate. That rate is known as our scale factor, and it's given the variable of k. And that indicates whether a figure is larger, enlarges, or reduces. If your k value is greater than 1, it's an enlargement. If your k value is less than 1, it's going to be reduction. And that less than 1 will be given in factors of, fractions. It's not necessarily those two, but that's just an example. Okay. As another part, as kind of like refresher before we get into problems, is our dilation rule. And it's only, this rule is only consistent if your origin is the center, which that's the only type we will be looking at. On the left, we have our coordinates. Those will be our coordinates for our pre-image. On the right, we have our coordinates for our image. So, in order to figure out what my image coordinates would be, I would multiply my scale factor by my x and y. So, for example, if I had the coordinates 2, 3, and I had a scale factor of 2, in order to figure out what my prime or my image coordinates would be, I would multiply 2 times 2 and 3 times 2. So my resulting coordinates would be 4, 6. The same would be consistent if it was less than 1. If I had 1/2, I would multiply those by 1/2. So let's look at this in practice. So for example 1, graph and label each figure and its image under a dilation with a given scale factor. Assume all dilation use the origin as the center. So I have triangle RST. R is -5, 1, S is -3, 4, and T is is 2, -1. And my scale factor is 2. So I'm going to multiply all of those coordinates, x and y values, by 2 to get my final coordinates for my image. So -5 times 2 gives me -10. 1 times 2 gives me 2. For S prime, -3, 2 gives me -6. And 4 times 2 gives me 8. For T prime, 2 times 2 gives me 4. And -1 times 2 gives me -2. Now, it's time to graph. So -10, I'm going to go off my graph and go up 2. Be R prime. S prime is going to be -6, up 8. T prime. And 2, or t prime is going to be 4 down -2. So t prime. Now it's a matter of, oh, I messed up. That's s prime. Yes. Okay, now it's a matter of connecting those points, which this is the challenge, without having a ruler. Whoop! And there you have it. Now looking at it, it's not as evident in this problem as it could be in other problems, which we'll see later on. When you think dilation, you think that it's going to get bigger consistently around it. However, we have to keep in mind what my center of dilation is. My center of dilation is the origin. So our shape is only going to get larger around that point, not necessarily the center of our polygon. So be aware of that. And this is all the work we have to show for these problems, is showing the transformation from my pre-image coordinates to my image coordinates. All right, example 2. I have rhombus JKLM with vertices J -10, 2, K -2, 8, and L 6, 2, and M -2, -4. My scale factor is going to be 1/2. So looking at that, I already know I have a reduction because my K value is less than 1. So I'm going to multiply each of these coordinates by 1/2, or if you like to think of it, divide by 2. Whatever works for you. So, time to figure out what our coordinates will be. So, -10 times 1/2, or divide by 2, gives me -5. 2 divided by 2 gives me 1. K prime -2 divided by 2 gives me -1. 8 divided by 2 gives me 4. 6 divided by 2 gives me 3. 2 divided by 2 gives me 1. -2 divided by 2 gives me -1. And -4 divided by 2 gives me 2. There's my coordinates. So my last step is to graph. So for J prime, -5 up 1. J prime. K prime, -1 up 4. K prime. Now, for this image, this is where it's going to be prevalent that my center of dilation is not the center of my polygon, but the origin. L prime is going to be 3 up 1. And M prime is going to be -1 up, whoa, I messed up. M prime's -2. There we go. -1, -2. Whew, close catch. All right, there we have it, folks. There's my coordinates as well as my image. And as you can see, my center of dilation is the origin, not necessarily the center of my polygon, right? Those are our 2 examples for our graphing. Now, here's another example where it does not give you a graph. It doesn't even want you to graph. It just wants you to figure out what would your coordinates be for your pre-image. So it tells me A prime is -10, 8. And it's the image of A after a dilation centered at the origin with a scale factor of 2. What are my pre-image coordinates? Well, I'm going to set up an algebraic equation between these coordinates. I know when I have a dilation, I'm going to be multiplying my pre-image coordinates by 2 to get my image coordinates. So if I had to rewrite those coordinates, I would have 2x, 2y is equal to -10, 8. And now I'm just going to break it up. So 2x is equal to -10, 2y is equal to 8. Divide by 2, divide by 2. X is equal to -5. Divide by 2, divide by 2. Y is equal to 4. So my resulting coordinates for my pre-image is -5, 4. All right, for example 4, try it yourself. Okay, pause the video and give it a go. I'm wanting to try to solve for my pre-image coordinates. My scale factor is 1/3. And my resulting for P prime coordinates is 2, 5. I know when I have a scale factor, I multiply my x and y values by that scale factor to get my image coordinates. So I'm going to set up an equation between that. So I have 1/3 times x is equal to -2, and 1/3 y is equal to 5. I'm going to multiply by the reciprocal to get rid of that fraction. So x is equal to -6 and y is equal to 15. So -6 comma 15 is my final answer. Our last type of dilation problem is everything's graphed. It's identified what my pre-image and image coordinates are. Now I want to solve for that scale factor. In order to approach these problems, you need to identify a set of coordinates that are corresponding. So D and D prime, or E and E prime, or F and F prime. It does not matter which coordinate set you pick because they're all going to have the same scale factor. You just have to pick one set and stay consistent. Then you analyze those coordinates. All right, I set up the same algebraic equation that I used in a previous problem. So I have my pre-image coordinates. I have my image coordinates. So I know that this set right here was multiplied by k to reach my prime set. So if I have 6k is equal to 2, I can divide by 6 to find k. So k is equal to 2, 6, or reduce would be 1/3. I chose to use this whole number set instead of 0 because 0 will not give me an accurate answer. 0, anything multiplied or divided by 0 will equal 0. So you want to pick a non-zero number to solve for that k value. All right, looking at my other set of problems for W, I'm going to do the same thing. It doesn't matter which set I pick. If I pick X or Y values, just pick one because your scale factor is consistent for both. So I'm going to take my pre-image coordinate of 2 times k to equal my image Y value, which is 8. Divide by 2, divide by 2. My k, or scale factor, is 4. Not too shabby, right? That's all I have for you today. You have watched your agenda video. You have watched your dilation video. Your last step is to complete the drag and drop on Google Classroom. Please let me know if you have any questions. All right, and have a good day, guys.